Right. So this is 24th question. That question is 2012 past paper, I think. So so 2012 they had the limits, so no problem. So now without limit you do. So using what we have learned so far. Have you done? Anyone have you done this question? Yes. Have you done this question? Okay. So we will learn this. We can do this integration separately. That is sine cube x dx minus cos cube x dx. This is one method. There are many methods to do this question. So what method I am going to do here, what we have practiced so far. So last class also we did that. So now I can do, I can keep one sine square x into sine x dx, right? Yes. Similar this one, cos square x into cos x dx, right? No problem. So I can write this sine square x as a 1 minus cos square x. At the same time, I can write this sine x dx as d cos x. And I have to put the minus here, somewhere else. Somewhere else I have to put the minus because d cos x is minus uh, sine x, but this is plus no, so I put minus here, right? So this is d cos x. Then minus the same way. So integration of cos square, I put 1 minus sine square x. At the same time, I can write this cos x dx as a d sine x. So here I don't need any minus. Now the answer. So what is the answer? If you integrate one respect to cos x, that is cos x. If you integrate cos square x respect to cos x, then cos cube x by 3. Understood? Minus bracket. If you integrate y respect to sin x, sin x. If you integrate sine square x respect to sin x, sin cube x by 3. That's it, plus c. That's all. If you want, you can simplify. So that's it. So using the knowledge what we gain, so you can do anything, right? Okay, so 34th question. Just copy this. 34th question. That is almost 2012. 2012, they put the limit here 0 to 5. So I will teach that what is limit there. So that is definite integrals. Okay. So, right. So I will erase this. Okay. So 35th question. Then after that, we will do another theory. So 35th question. So how you can deal with this? Sin x into e to the power cos x dx. Sin x into e to the power cos x dx. Let's see how you can do 35th question. So I erase this one. 36th question is, so integration of e to the power tan inverse x over 1 plus x squared dx. Okay, so these are similar questions, right? I can erase this. Later you can multiply and simplify. I didn't do that. Later you can multiply and simplify. So right. So we talk about this one. So you know that this is sin x dx. You can write as e to the power cos x d cos x. But d cos x will create the minus. So I put the minus in front of that. D cos x will be minus sin x into dx. But I am having sin x dx. So minus c e to the power t dt. What is that? If you integrate e to the power t, e to the power t is the answer. Say e to the power x dx, e to the power x is the answer. E to the power y dy, e to the power y is the answer. E to the power cat d cat. Then e to the power cat is the answer. Plus c plus c plus c. Now you are okay. Tell me e to the power cos x d cos x. Then e to the power cos x is the answer plus c. That's it. What about this one? So now obviously you realize, that's easy because e to the power tan inverse x, and this is going to be this 1 over 1 plus x square is d tan inverse x. Oh my goodness. Then answer is e to the power tan inverse x plus c. That's it. Okay. Is it clear? Question number 36. Right. So we will go move to the another thing. So now still we are in the map in the top, the very basic stuff. But we have gone through many type of questions and we have gone through some past papers also, first part also, right? Because we know the basic stuff, how to deal with the D and why it's coming and everything, right? So now put the heading, put the heading, put the heading is integration of f of x and f prime x dx. This is the form. So second form is ln mod of f of x plus c. So this is the second standard form. Okay, previously we did x to the power n, then we developed that ax plus b to the power n, then we developed that f of x to the power n and df of x, that is f prime x into dx. So now we have to go through this. This is very important and very, very important in integration. Okay, it is this one. Right. It is this. It is this. And it is. Okay, so this is the rule. So we are going to find, we know how I came like that. We know that because just I can show you. So f of x, because since we know the basic stuff in integration, very basic. So we can identify what is there. So f of x, this f prime x dx, you can say that is df of x. So tell me, if 1 over x dx, what do you put? Ln x. 1 over x dx ln x. Here x, here x. Tell me 1 over t dt ln t. Tell me 1 over y dy ln y. Likewise, tell me 1 over f of x df of x. Oh, that is ln f of x, man. Oh. See? So now you don't need to think like this. We are wasting some time now, so you have to write d and something like that. So this one you can straight away use. What you can do is straight away you can use this. So if anything, so how to explain this? I'll explain this. Denominator f of x, anything, the differentiation of the denominator in the numerator, immediately you can write f prime x. Sorry, ln f of x. Okay, so I erase this because just to show how it came. So now you can follow this. Now you can follow this. say example. So write down example. So that's an easy example I use always. That is sin x cos x. So that means cot x, integration of cot x. What is integration of cot x? So before you write anything, so differentiation of this in the top. So answer is ln sin x plus c. What is the differentiation of sin x cos x? That is in the top. Then immediately you can write ln sin x plus c. So I can go for another example. So tell me, so x squared plus 3x plus 1. So 2x plus 3 into dx. So first you have to check what? So differentiation of this, whether the differentiation of this exists in the numerator. Yes, this is 2x plus 3. Yes, of course. So immediately you can write 3x plus c plus c. Okay, so is it clear? Anything? Okay, that's fine. So we will continue the questions right now. So first of all, now copy this and start with 37th question, question number 37. Okay, so that is simply easy one. I hope this is going to be easy one. Sin x plus cos x. Okay, sin x plus cos x. Cos x minus sin x. So this is pretty easy. You will check it and you will do. Right. Doubts. Let's see the doubts. Why you are putting modulus? Yeah, modulus is expected because logarithm inside the logarithm cannot be negative number. No? Logarithm inside the ln cannot be negative number. So even if anything negative there, it makes a positive and it will take the value only. So that's why the ln modulus is there. Okay, so because of the logarithm. So sometimes if it's negative, so we have to make it positive and take the value. So to make it positive mean automatically if you put modulus, then automatically it will make positive if it's negative. Okay. Any problem at all? No. No problem. Right. Right. So 37th question. I erase this one. So I go for 38 also. Then later I'll do 38 one. So that is x squared plus 1 x dx. The easy one. I erase this one. 39th question is going to be x squared plus 2x plus 5. That is going to be x plus 1 dx. Okay. So 40th one. That's pretty interesting. dx over x into ln x. Okay. Okay, try this. I'll give 1 minute. 1 minute enough. 1 minute enough. Okay. So 1 minute enough. Okay, guys, hopefully you have done. Let's see. Right. Right, that's fine. So let's see. We will start with this one. So check whether differentiation of this sin x, that is cos x, yes, if they are. Straight away you can put modulus sin x plus cos x. Sin x plus cos x plus c. Don't forget that to put plus c, and you have to write that c is an arbitrary constant. But here we are running in hurry, so you don't need to write now, but in exam you have to. So what about this one, 38 one? So the differentiation of this in the top, no, that's not there. Why? Because it should be 2x, but there is x. So what you can do? You can put the 2.5. Is it clear? Yes, you can adjust that 2x and half. Then the differentiation of this in the top, 2x. Yes. So what you can do? Ln x squared plus 1 plus c. Now you can put the ln of this. Note that side input modulus for x squared plus 1. Why? X squared plus 1 always positive for all the x values, all the real values of x. All the real values of x, x squared plus 1 is positive. So I didn't put the modulus. Okay, so the half is there. I forgot the half. Half is there. So we have to put the half. That's it. That's good. The next one. So what about this? So if you differentiate this 2x plus 2, but here x plus 1. So if you multiply by 2, then you can form it. So then I put multiply by 2 and put half. Now half, right? Then that this is logarithm, and I don't put, I think this is, check the delta, then it's negative, so it's not a modulus. So x squared plus 2x plus 5 and plus c. So this is very interesting one. How? Because you can write this ln x 1 over x as here 1 over x. Understood? 1 over x down, x down. So you can put it as a 1 over x in the numerator. So now you can see differentiation of this there, 1 over x. So answer is ln x. Ln x plus c. Ln inside the ln x. Okay, so ln x can be negative, so I put the net modulus. Is it clear? So there are 40 questions. So hopefully I erase this. So we'll start. Okay, so further we will do. So 41, let's see. Okay. Dx over 1 minus x squared and square root into sine inverse x. Let's see. 42, I erase this one. Okay, 42. Right. Dx over tan inverse x into 1 plus x squared. I erase this one. 43. 43. Integration of so e to the power x plus 1 e to the power x dx. 44. So it's 44. Question number 44. Then I can tell you something. Tan x dx. Let's see how things are going for the tan x. Then 45. Very important question. 45. Okay. So hopefully you have done. So I'll do the sec x dx. That is a finally 45th one, sec x dx. Okay, I will do this from the beginning. Here, this you can do, you know that this is sine inverse x, you can keep it down. So you can write square root of 1 minus x square as a 1 over 1 minus x square and square root dx. So obviously this is differentiation of this in the top. So ln sine inverse x plus c. That's very great. What about this? The similar one, similar way. So tan inverse x you keep here 1 over 1 plus x squared. So 1 over 1 plus x squared you can put it in the top. So answer is ln tan inverse x plus c. Okay, so what about this differentiation of this e to the power x, then e to the power x plus 1, 0. So straight away you can put e to the power x plus 1. So plus c. Tan x, there is a small thing you need to do, sin x over cos x dx. Okay, so then what you can do, differentiation of this in the top, no, but you have to put a minus and minus out. So minus ln cos x plus 6. So later you can write that ln sec x because you take the minus there, cos x to the power minus 1, 1 over cos x, then ln cos x, ln sec x. So you can write like that also later. Minus ln cos x if you integrate tan x or ln sec x. So finally, 45th one. I erase this one. 45th. Anyone did 45th question? Integration of sec x dx. So let's see. Anyone did it? Let's see. I'll check. So where are? So the main thing is you have to follow the class. If you otherwise you know what is, or you don't know what is happening. You don't know the continuity what is it. So you may know here and there. You don't know what is the continuation. So there are many techniques in integrations. Integration not like the syllabus. Okay. So anyone can teach, anyone can learn. But techniques are very important that helps in the exam. Right. So sec x. So I erase this one. So before I go for the sec x, then there is a 46. I say sec x. Okay, give me a second. Okay, so we'll do this continuously. Right, cosec x 43, I erased that one. And I erased the last part also. Here, so very important one is sec x. So what you can do, 1 over cos x, 1 over cos x means it's very hard to find. So what we can do, top and bottom, we multiply by sec x plus tan x. So that is very important thing you need to memorize. So this is the way, top and bottom, we have to multiply by sec x plus tan x. Why? See will you multiply this into this sec square x, this into this sec x tan x. Now tell me here sec x plus tan x dx. Okay. So now tell me, so what is the answer? The differentiation of this sec x is sec x tan x. Differentiation of tan x is x square x is there. So ln sec x plus tan x plus c. That's it. Understood? You see that. The same way cosec x. Cosec x, you multiply top and bottom by cosec x plus cot x. Cosec x plus cot x. Okay. So then you will understand. So if you multiply that cosec square x plus cosec x cot x over cosec x plus cot x. So what is the differentiation of cosec x minus cosec x cot x? What is the differentiation of cot x minus cosec square x? But unfortunately, I'm not having the minus there. But what I can do, I multiply top and bottom by minus. That means so like this. Now okay. Now answer is negative ln cosec x plus cot x plus c. That's it. Very important. Question number 47. Question number 47. Question number 47. Okay, so question number 47 is cot x, tan x, cosec x, sec x, everything gone. So let's see how you can do e to the power x, e to the power x minus 1 over e to the power x plus 1 dx. Now I'll tell you. I'll tell you the story. How nice that 47th question. Now I erase the 48th to 47th. So go for the 48th integration. Okay, so 1 over, so no, cos x over cos x plus tan x. Cos x minus tan x sin x. Okay, dx. How you will do that? Oh yeah, I put plus plus, that's better. So I erase this one. Hope you understood. I'm going to erase this one. 48. 49th question I put here. 49th question. 49th question is 1 over 1 minus tan x dx. 50th question is, no, I think it's better, okay, not to write this one. Do anything later, right? 49th is Okay, so sine. Okay. That is e to the power x, done e to the power x, this is done, cos x done, everything done. What to do? Everything okay. So I'll do something else. So x plus sine x, x plus sine x into 1 minus cos x. So 1 plus cos x. This right away you can put easy. 49 is the easiest one. 50th one is, I can say, so I can say 1 minus tan x. Why not? Over tan x dx. Okay, so these questions, how 50, we reached the half century, half century. Oh, right, all of you, right, half century. So the next few classes we will reach 100 questions. Right, so normally I do 100 questions in integration first for the theory, then we start the practice questions, right? Hopefully. So do it. Do it, do it, do it. Hope you are doing. Just please, first of all, copy the questions, right? Sometimes if it goes off, then it's a matter. So copy the questions, so I'll quickly. Okay. So quickly we'll do this one. So you will understand these are some questions are a bit hard. You are looking into. It's not a straightforward question. So differentiation of this not in the top. No more anything. No more. So what I can do? There are many methods to do this. There are many methods to do this. I'll do one method. I'll do one method. I can write this e to the power x plus 1 and minus 2. Is it clear? Yes. So first of all, I erase this one because I need space to do this question. Sin a cos x plus sin x, I erase this. So individually divide this over this. So 1 minus 2 over e to the power x plus 1 dx. So now it's okay. But here again you have problem how to integrate this. Differentiation of this not in the top. But anyhow you can do. How? Top and bottom I divide by e to the power x or multiply by e to the power minus x. Then 1 e to the power minus x. Do you understand that technique? Do you understand that technique? That's right. This is not in the syllabus. Not in the syllabus means the syllabus they won't tell like this. So the techniques must be you have to learn in the class. Otherwise, no way. So you will learn only the theory. That means okay, if the differentiation on the top, then you will do. But the questions are not like straight forwards here. So top and bottom I divide by e to the power x or multiply by e to the power minus x. See? Now the differentiation of this there. Why? E to the power minus x is e to the power minus x into minus. So I can take the minus there, this minus there and make it plus. So now answer. If you integrate 1, that is x plus differentiate to take the 2 out, differentiation of this there, then ln 1 plus e to the power minus x plus c. So this is one method. There are many methods in coming classes. I will tell you. Here there is no time to tell. So there are many other methods also. I think I can tell somewhere there. So 48th question. So before I go for the 48, I can finish this right here. This is easy. Differentiation of there. So ln x plus sin x plus c. That's it. Ln x plus sin x plus c. That's it. 49 is okay. So then I go for the 48th one. That is cos x over cos x plus sin x. There you are. There you are. How to do this one? How to do this one? Cos x over cos x plus sin x. So there is an interesting thing you have to do this. Do now. Right. So what I can do is there is a small technique. Later I will tell what is the technique. Now I just do. Later the next class we will discuss about that. I'm going to write the cos x as uh, sin x plus cos x, right? Minus sin x minus cos x. Is it clear? Okay. Shall I write like this? Then cos x, then half. Shall I write like this? Shall I write like this? Is it clear? Because sin x plus cos x minus cos x means sin x gone. Cos x minus cos x, then 2 cos x. I put half, then cos x. So the same thing. Oh my goodness, how to think that? So there is a way to think. That's why I'll tell you that. This divide by this one. Oh, now sin x minus cos x divided by cos x plus sin x. Integration of dx. Now tell me. Now tell me. Now tell me. Integration of differentiation of cos x is minus sin x. Differentiation of sin x is cos x, but this is other way around. Multiply by the minus. 1 minus, take the minus inside, then put the right the cos x first minus sin x next. Oh my goodness. Cos x plus sin x. How nice. How nice? Same nice. Half. So answer is not logarithm here. You have to write the answer half. And x, if you integrate 1, that is x plus differentiation of cos x minus sin x. Differentiation of sin x, cos x. Then ln mod of cos x plus sin x. And bracket close plus. That's it. How heavy this question. You have to come up with your own idea. So the 50th one, that's the homework. That's the homework. So we will talk about that later. That's the homework 50th one. Okay. So mm, mm, mm. Okay. So that's the homework. So you can do that. So we will conclude the class right now. So we are finishing the one part, that is 1 over that is ln form. Already we finished that f of x to the power n ln. So the next class we will be continuing doing tan inverse, then square root, then sine inverse. After that by parts, after the substitution, after the special, end of the integration. Okay, bye guys.